Multiplication of decimals. How do we multiply decimals? Well, we multiply just like we did with whole numbers. But the kind of quirky, strange thing with decimals is, where do you put the decimal point in the final answer? I mean, I know you can work it like the regular way we multiply, but where do you put the decimal point? So there's a rule about where the decimal goes, and I'm going to explain it through this next example. It says if there are n digits to the right of the decimal point in one number, and m digits to the right of the decimal point in the second number, you're going to go ahead and just multiply the two numbers together, ignore any decimals, just pretend they're whole numbers. And then at the end, you're going to place the decimal point so there are n plus m digits to the right of the decimal point in your final answer. So let me show you through an example. We're going to multiply 3.16 times 2.4, right? 3 and 1600ths times 2 and 4/10, using just a standard regular algorithm. So it says you take 3.16 times 2.4. We don't line the decimals up here. Okay, and what I want you to notice here before we even get started multiplying, this number has 2 decimal places. To the right, see the 1 and the 6, there's 2 decimal places. This one has 1 decimal place to the right of the decimal. Just throwing that out there, just kind of making a mental note here. All right, now we're going to multiply, ignoring any decimals. So the way we do the multiplication algorithm is 4 times 6 is 24, so we write the 4, carry the 2. 4 times 1 is 4, plus 2 is 6. And then 4 times 3 is 12. And then you scoot over, put a 0, and now we're going to multiply the 2. 2 times 6 is 12. So put down the 2, you're going to carry a 1. 2 times 1 plus 1 is 3. And then 2 times 3 is 6. And what we're taught to do, right, is then you add all that together. So we have a 4, an 8, a 5, and a 7. So then the question is, where does the decimal place go? Well, if one number has 2 decimal places and the other number has 1, we're going to do a total of 3. We're going to add those together, and we're going to get 3 decimal places. So you're going to put the decimal right there so that you've got 3 places behind it. So you add the 2 and the 1 together to get the 3. So I don't know if you remember that from when you learned how to multiply decimals. Probably been a while since you've done it by hand, but that's why. Now let's look also at an explanation as to why it works with fractions. So 3.16, right, that's ends in the hundredths place, so that's 316 over 100. 2.4 ends in your tenths place, so that's 24 over 10. When you look at 110 in their exponent form, that's 10 squared and 10 to the first. And when you multiply like bases, you add the exponents, and so you end up getting 10 cubed because you multiply straight across the top and straight across the bottom. So you get this huge number on the top and 10 cubed. And 10 cubed is a 1 with 3 zeros. And so that thousandths tells you that you're going to end in your thousandths place. So why you end up with 3 decimals, you can see it directly right here if you convert to fractions. So that's just further proof of why this little trick works. So when you are multiplying decimals, if the denominators are 10 to the m and 10 to the n, the resulting product will contain 10 to the m plus n. It all goes back to exponent rules. So there will be m plus n digits to the right of the decimal point. Now another way that we learned to multiply was to use the lattice method. So let's see how the lattice method can help us with decimals also. So here's what we're going to multiply. Same number. We're going to multiply 3.16 times 2.4. And the way we do the lattice is you put one number across the top and one on the right. And I'm going to put a big fat decimal here. And that's kind of the intersection, kind of where this next column starts. So we have 3, 1, 6 column. We have a 2 and a 4 column. And remember, when you multiply a row times a column, it's always going to be a single digit times a single digit. And you can only ever get one place value or two place values. You're either going to get a single or a double digit number. So I'm going to start with 3. 3 times 2 is 6. So I don't need both digits, I just need the 6. And I'll just put a 0 as a placeholder there. Now I'll do 3 times 4. Well, 3 times 4 is 12. 2-digit number, so we write it like that. Now let's do the 1. 1 times 2 is 2. 1 times 4 is 4. Now let's do the 6. 6 times 2, that's 12. 6 times 4, that's 24. So we've got this thing all set up. Now you extend your diagonals. And remember, you accumulate all the numbers in each diagonal. These will be your place values. So this is a 4. 2 plus 2 plus 4, that's going to be 8. 1 plus 2 plus 0 plus 2, that's going to be 5. And 6 plus 1, that's going to be your 7. The question is, where does the decimal go? And this is the coolest thing. I don't know why I like this so much. I just really like this. Here's how you do the decimals. So here's your decimal. We're going to put him right there, in between the 3 and the 1. And in between the 2 and the 4, right there, I'm going to put my decimal. The decimals are going to run until they meet up, right? So he's going to go down a block. This guy's going to run over 2 blocks until the 2 meet up on the playground, and then whee, they go down the slide together and they end up right there. So they walk however many blocks they need to walk to meet up, and then they slide down that diagonal, and it will put the decimal in the right spot, and you get 7.584. Of course, you can check your answer with a calculator, but the point is you don't have to use a calculator. So it breaks it up into 6 tiny problems. You accumulate in the diagonals, and then now these decimals get a ride down the slide once they get to the playground. So I don't know. I just really love that. I wish I had been taught that when I was a kid in school. I think I would have really latched on to that method. It works good for my brain.